Not now, it's going to be late. June is not there. Again, your t-shirt, some problem with the t-shirt. Okay, he's not wearing the uniform. That's supposed to be.
हमें छुपा रहे थे गरीब
निकालो लिख नीचे
हाँ भैया
ये उधर से क्या कर रहे हैं तेरे में थोड़ा सा टैग है ना कोई चीज Okay, boys, sit down.
She. मैंने इनसे बात करी
They're okay with our places. I don't want to see anybody getting disturbed. Somebody would like to come here? Everyone has a notebook, textbook. I don't want anybody to be borrowing, taking whatever it is. No confusion. Ready? Just as a recap, I want you to understand something. Now, this is one chapter. Pay attention. This is one chapter which is very volatile. That is volatile, yes. That's what we used to always say when we were as students. Whatever you learn, it's very difficult. It just disappears. So it's always you have to keep on revising whatever we have done. What is a hydrocarbon? I'll ask you a series of questions now. What is a hydrocarbon? Yes? What is a hydrocarbon? You are almost close to it, but it's not completely right.
Different forms of carbon when it combines with the hydrogen atom.
When a molecule consists of only hydrogen and carbon. Is that okay? When any compound consists of only hydrogen and carbon is called as a hydrocarbon. For example, if you can talk about, what is that?
Methane.
Methane. Is methane a hydrocarbon?
Yes.
Yes. So how do we define what is a hydrocarbon? Hydrocarbon is a compound which contains hydrogen and carbon. Okay, so it's a carbon compound. So when we are talking about something that has got a CHO, can you give me an example which contains CH and an O?
Glucose.
So we have got C6H12O6. This is also a hydrocarbon, but in addition it also has got an oxygen. So the fundamental unit by which other compounds are formed is nothing but your hydrocarbon. Okay. So now again, when you are talking about a hydrocarbon, we have already seen what are the two divisions that we have read about.
Saturated.
Very saturated. It is saturated and unsaturated. So we have got saturated and it is an unsaturated hydrocarbon. What does it mean by, what do you say it is hydrogen? It is saturated.
Single covalent.
Single covalent bond present where and where?
Between carbon and carbon.
Yes, between a carbon atom. Okay, between an adjacent carbon atom. Unsaturated, what are the two types
Double
here?
and
Double.
triple.
Okay, so it is a double bond and it is a triple bond. Okay. What are these called?
Alkane.
Alkane. Double bonds?
Alkene.
Alkene. And these are alkyne. Okay, Virat, your chance. Give me a formula for alkyne. General formula for alkyne. C. Yes. CN.
अरे formula नहीं.
General formula.
General formula. ये.
General formula.
CN.
Minus 2. Did you understand? The first one, saturated is CnH2n plus 2. For the first one, okay, it is CnH2n plus 2. For the double bond, it is Cn what? H2n. And for the last one, minus 2. Okay, so it is CnH2n minus 2. This is something that you must remember. Shh. I said no, Dr. when I talk. Is that okay? So we have also done something about functional groups, right? A functional groups is OH group, CHO group. Okay, it could be a halide group, it could be a ketone group. Some of them we have already discussed. These are These are also. Did you meet Meena ma'am?
Yes.
These presence of a single bond, presence of a double bond or a triple bond is also a type of a functional group. Have you got it? If at all it has got a triple bond, all those members of the family they behave in the same manner. We have done group of alkanes, we have done a list of alkenes, we have done a list of alkynes. So if at all it has got a double bond or a triple bond or even a single bond, they show a particular characteristic feature. So even a single bond, double bond and a triple bond along with your other functional groups like OH group. What is an OH group?
Ethyl. Alcohol.
All. Alcohol. Remember the last two words will be all. Okay. So it will be what is CHO group? You have to revise, children. You have to revise this. Otherwise you'll be stuck. Look at your books quickly. What is it? Al. Al means what? What group is that? What is it? Aldehyde. What is it? It is an aldehyde. Okay? Because it is an aldehyde, it will be ending in al. This is an alcohol, so it will be ending in all. Okay? If at all there is an acid, what will be the functional group look like? Yes, carboxyl group. What does it look like? It is COOH. Okay, so because this is a carboxyl group. Is that okay? Is that okay? You remember till now? Yes, you have to keep on refreshing. Okay. Now look at me. We revise quickly the names for number of carbons. Meth. Proper. Bute. Pent. Okay. Quickly, huh? Bute. Now mixed. I'm asking mixed. Pay attention. Chorus. Bute. Bute. Very good. Okay, so we know. So menthol, methanol. Okay, we'll talk about alcohol groups. 1 carbon होगा तो methanol. 2 carbon, methanol. 3 carbon, propanol. 4 होगा तो butanol and pentanol. Did you understand? Okay. Hexanol and so on and so forth. We'll not usually more than 5 is never asked in the understand. Did you understand how the functional groups are formed? Okay, so based on the name, first we'll see the number of carbon atoms present. Then we start with that and add the functional group. That becomes your functional group. What did we do last? We have given you variety of compounds talking about the functional group itself. Look at your notebooks, everyone. See the last page, what we have done. Okay. Nomenclature. So what is nomenclature? This is how we are going to be talking about the different compounds. Okay. So today we'll also be talking about the chemical properties, some of the chemical properties, and I'll also be taking a little bit of revision towards the end. When we talk about chemical properties, basically we'll be, take it up, talking under 4 broad subheadings. The first one will be combustion. Okay, combustion, oxidation, addition, and substitution. Now these chemical properties, we are specifically going to be talking only about carbon compounds because this chapter deals only with carbon compounds. In the first chapter, what did we talk about? Types of chemical reactions. We have seen redox reactions, additions, okay, decomposition reactions, double displacement, displacement reactions. So similarly, we are going to be talking about this. It's going to be pretty simple for us. Okay, let's look at the very first one. What do you mean by combustion?
Burning or
Burning,
a
correct?
substance in the
Yes.
presence of oxygen.
Okay, suppose we are talking about paper. Suppose we are talking about paper. Is it combustible?
Yes,
ma'am.
What about cloth?
Yes.
So when we say it is combustible, it basically says that it can burn in
In the presence of oxygen.
of air. Okay, so all your combustion reactions here is carbon compound burning with oxygen. So combustion is actually a type of oxidation.
Oxygen, yes.
It's a type of, but there's a specific requirement for combustion. What happens when you burn paper? Heat is,
And
yes.
heat is.
Okay, so it's basically light as well as heat, okay? So some kind of energy is also released. So let's look at the first one, okay? Everyone has your textbook right there, right? Look at combustion. Carbon in all its allotropic forms. You know what is allotropic? I've told you. Different forms. Different physical forms, allotropic forms, okay? Burns in oxygen to give you carbon dioxide along with the release of heat and light. So what is heat? Heat is also a type of energy. Light is also a type of energy. So heat energy and light energy is given out along with carbon dioxide. Most carbon compounds also release a huge amount of heat and light on burning. Let's look at the very first one. Okay. Well, what is the first one? Look at the first equation. Carbon. In whatever form you take, carbon in the form of coal, carbon in the form of graphite, even if you are taking carbon in the form of diamond, of course it has to be heated under certain special conditions. When you're heating it up in air, what is formed?
CO2.
Obviously, there's nothing else which is here, so it is going to form carbon dioxide. Along, of course, along with your heat and light. So you have got heat as well as light, which is going to be used. This is, of course, a balanced reaction. Look at the very next one. Yeah.
What are the conditions for the formation of carbon monoxide?
Carbon monoxide under limited conditions of oxygen. Okay. Second one. You know what? Many times, you must have seen in the papers that people die of carbon monoxide poisoning.
हीमोग्लोबिन में चला जाता है हीमोग्लोबिन में
Mixed
CO चला जाता है
confusion. क्योंकि वो सबसे ज़्यादा क्या होती है इंटरेक्ट करते हैं।
So how will you explain it? It has got a greater
Affinity.
affinity, not infinity.
हाँ वही affinity वही।
Affinity. Okay, it has an affinity for carbon monoxide. So hemoglobin is capable of picking up carbon monoxide more than it can pick up oxygen. Now, usually what happens is, because he asked me this question, I'm explaining what are the conditions, under limited conditions of oxygen, especially in cold regions when people are staying in small hut, and in order to keep them warm, they have that coal which is burning. Cigarette होते हैं ना? So that coal is burning. So what is happening when the coal is burning? It is taking away the oxygen. So people who are sleeping in that room don't have much of oxygen, but because this is getting burned, carbon monoxide is released, and that's when they suffocate to death. Okay, you find that? Look at the next one. Come on, this you can do. The next one is CH4. What is CH4? Methane. Don't get distracted. If you want, you go and sit down in the last page. Don't get distracted. What is this? This is methane. Okay. We are showing the same thing. Combustion taking place with oxygen. So what do you think will happen? What do you think is happening?
And
Carbon will combine with
dioxide.
oxygen, carbon dioxide. Hydrogen will also combine with oxygen to form water. So what is happening here? Carbon dioxide and water. Who is that talking? Who is that?
I wasn't.
No, don't test my patience. Don't test my patience. To a certain extent, I'm okay, but beyond it, I will not allow anything. Is it balanced? No, balanced. Come on, everyone. Take down the first equation. Take down the second one. First equation is already balanced for you. Second equation, balance. Hurry up, hurry up.
Done.
Good. Did everyone get?
Yes.
Look at oxygen, it's an odd man. Okay, what is the first rule I tell you? Make odd man even. Obviously, you cannot put anything here. We put what number will you put here? Put a 2 there. So, hydrogen becomes 4, that's okay. What happens to oxygen here? 2 plus 2, 4. Done? So, the second one is also done. Plus what? Plus what else will come there? Heat and light. Make sure that you write it down. Because of combustion, whenever we talk about combustion, it is, whose book is that? Give it to me. You come here. Slowly all of you are going to be shifted to each bench. Sit here. Is that okay? Did you see how it is similar combustion for carbon or even for hydrocarbons? It's very similar. Next one. What is the next compound? Can you recognize what they have given? What is this? What is this? CH3, CH2, OH plus oxygen. What is this? How will you label it? How many carbons are there? 1, 2. If it is 2 carbon? X. Okay, X. Ethane. No? X. Can you recognize the functional group here? OH. OH means what? Alcohol. Okay, so it is ethanol. Or you can also call it as ethyl alcohol. Okay, so this is your ethyl alcohol, or you can say it is ethanol. So what is the third reaction? It is combustion of ethanol. Write it down. This also has got carbon, this also has got hydrogen. Yeah.
Remember ethanol is C2H5OH.
This is the same thing. CH3, CH2, OH. आपने क्या बोला? C2H5OH. समझा? Ethanol or ethyl alcohol.
Why have they like changed?
Yeah, why? You tell me. Can anybody tell me why we can write it in both ways? This is giving you a structure. This one, CH3, CH2, and OH. You understand? Look at this.
Okay.
The first carbon has got a CH3. Did you understand? Second carbon has got a CH2 and there's an OH. So this is a better way of writing ethyl alcohol. Basically because it is telling you how many carbons are present or how many hydrogens are present for each carbon. But it is same. You can write either way. Okay, now coming back to this equation. What have we written? Ethanol plus oxygen, what is formed?
Carbon dioxide. and
Once again, it is going to be carbon dioxide plus water plus
Heat and light.
Heat and light. Here also. Okay. Now try to balance it. How many hydrogens do we have here?
6.
Sure.
Yes.
3 plus 2, 5. 5 plus 1, 6. Here. You have only 2. So what do we do?
Darling.
Put what number?
3.
3. Okay. Then, if you put a 3 there, how many carbons do we have here?
2.
2. What do we put here?
2.
Put a 2. Okay. Now you find out about oxygen. How many here?
3.
3.
7.
Here?
3.
3.
Only 3. So some numbers should come here so that it becomes 7. What will you do?
3.
So if you put a 3 there, 3 2s are 6. 6 plus 1 oxygen, it becomes a 7.
And
Didn't understand? Be honest.
Ma'am,
I will do it again.
Sabka, why is all the products carbon dioxide and water?
That is because we are talking about combustion of carbon compounds. So any carbon compound that you take, hydrocarbon, I am not talking about any other carbon which has got nitrogen or sulfur or whatever it is. If it is carbon or carbon compound, hydrocarbon, whenever, whatever you do, the combustion is going to give you carbon dioxide and water. Because there's nothing else here. Did you see that? Okay. Suppose you are talking about a protein molecule. It will have carbon, hydrogen, oxygen and nitrogen. So obviously it is not going to be this. So only if you are talking about a hydrocarbon, these are the ones which is going to come up. Okay. Those of you who did not understand, let's look at the balancing once again. Okay. Let's look at the number of carbon on the right hand side, and here we have the left hand side. How many carbons are here? 1 and 2. Okay, so we first fix that. Let's look at the number of hydrogens. Here we have 2, and here we have got 3 plus 2, 5. 5 plus 1, that is 6. So if there's only 2 here, what number should we put? I should put a 3. Okay. So now I know that my carbons are balanced. Hydrogen is also balanced. Now we have to look at oxygen. Okay. Count the total number of oxygens which is present on this side. 2 2s are 4, that makes it 4. And 4 plus 3, that makes it 7. So on this side we have got 7 oxygens. Let's see here. Right now we have not put any number. There's only one oxygen here and there are two oxygens. So obviously this is the only place where I can put some number by which I can get the number 7. So what will I put here? I'll put a 3. So if I put a 3, 3 twos are 6 and 6 plus 1, the oxygen will be 7. Therefore, it's a balanced equation. Are you done? Did you understand? Clear? Okay. Plus, did you write what else?
Heat and light.
Very good. So you find for combustion, we have got hydrocarbons or a carbon compound, which is basically giving rise to carbon dioxide and water. Okay, come on, take down this statement now. Carbon in all its, come on, write it down. After writing all the 3 equations, carbon in all its allotropic forms, allotropic form, burns in oxygen to give carbon dioxide with the release of a large amount of heat, and light on burning. Large amount of heat and light on burning. Okay? Now I'm asking you a question. You would have probably seen people using firewood for cooking food. Sorry. Do you think a firewood is as efficient as the gas that we are using?
No.
Why?
Because the naturals,
One by one. Yes.
because naturals uses fuel, uses a gas which is more combustible than wood.
Any other point?
Now, firewood is mostly used in the villages which are not that urban. So, because of when we burn the firewood, it has a very dangerous gas which infects the humans. So, natural gas is better than this firewood.
Anything else?
The firewood will probably get exhausted faster than the normal gas.
Okay. My question was, is it as efficient as our gas which we are getting, pipe gas or
हम ऐसा स्टोव वाले का सब बना सकते हैं ना?
तो वैसे खाना बनाते
It's okay. Did you notice something about the soot or the smoke which is formed? Which has got more soot and which has got more smoke firewood. Okay. So this one thing that you have to always remember is when you are talking about different type of carbon compounds, some of them may be hydrocarbons, okay? Some of them produce a sooty flame. What is a sooty flame?
Small particles.
Yes.
Suspended
Sooty
particles.
flame is nothing but something that produces a lot of smoke. Correct? And the flame is also not the blue flame that we get in a gas cylinder or the pipe gas. When you switch it on, you actually get a nice blue flame. Okay? So that means to say the calorific value, that means the heating capacity is more. But if it is a yellow flame, that means to say it forms more of soot and therefore obviously the heating capacity is less. Okay, so what is it called? It's called as a calorific value is much lesser for a firewood as compared to the others. Okay, so this is usually seen in a sooty flame. You usually find for an unsaturated hydrocarbon. Okay, but if you are talking about a clean flame, okay, it is usually going to be seen for a saturated hydrocarbon. Question for second. Why is your here? Concentrate here. Right? Okay. Saturated hydrocarbons. Last paragraph. Are you ready? You want to read? Yeah, read.
Saturated hydrocarbons will generally give a clean flame, while unsaturated carbon compounds will give a yellow flame. lots of black smoke. This results in a sooty deposit on the metal plate in activity 4.3. However, limiting the supply of air results in incomplete combustion of even saturated hydrocarbons, giving a sooty flame. The gas.
So is a sooty flame favorable for us? No. Suppose you are putting a vessel on a gas stove which is giving you a sooty flame. What happens? The bottom of the thing will be blackish. Okay. So obviously it is going to reduce the efficiency of the flame itself. So when do we get a sooty flame? If the compound is an unsaturated hydrocarbon. If it is a saturated hydrocarbon, then it gives a heat. So can you guess what type of gas is there in a gas cylinder?
LPGs.
It is butane.
Acha.
Butane and isobutane. What is
Four carbon.
butane? Can you imagine how the compound is going to be? 1, 2, 3, 4 single bonds and put the hydrogens. Got it? So it is a mixture of isobutane and butane, which is usually supplied in a gas cylinder. You understand? That is why we get a clean flame. Continue, please.
The gas/kerosene stove used at home has inlets for air so that a sufficiently oxygen-rich mixture is burned into a clean blue flame. We observe the bottoms of cooking vessels getting blackened. It means that the air holes are blocked and fuel is getting wasted. Fuels such as coal and petroleum have some amount of nitrogen and sulfur in them. Their combustion results in the formation of oxides of sulfur and nitrogen, which are major pollutants in the environment.
So what are we talking about? What are the two compounds that is mentioned there?
Sulfur and
Nitrogen.
What are the two
Sulfur oxide and
compounds?
nitrogen oxide. Sulfur and nitrogen.
Where is it present? Is it
Yeah.
present in hydrocarbons?
No.
Is nitrogen and sulfur present in hydrocarbons? No. What compounds is it present
Oxide
in?
form.
What is it present in?
Oxides.
No. Fuels such as,
Coal and petroleum.
yes, in coal and petroleum, that will, in addition to having carbon and hydrogen, it also has got nitrogen and it also has got some amount of sulfur. So what happens when you burn it? Sulfur will combine with oxygen to form sulfur dioxide. Nitrogen will also combine with oxygen to form hydrogen dioxide. So these two are going to pollute the air. Have you followed? So burning of coal or burning of petroleum obviously causes some amount of pollution. Got it? Okay. Make a note of it, please. Yeah.
Inlet means
Yeah.
inlet.
Inlet. Yes. Have you seen? Have you gone to the lab? Have you seen a Bunsen flame?
No,
You have seen. Okay.
one labs.
Yeah, I will get the lab here to the class. Usually a Bunsen flame looks like this. Okay. This is your stand and we supply the gas here and the flame is using. You must have seen this.
Yes, I can see.
Yes, ma'am.
Yeah.
That's
That's a Bunsen. And there's an inlet. Okay. So there is a ring. This ring can be adjusted. You can increase it or decrease it so that you can have an inlet. This is an inlet for your AC. Outlet and an inlet, that's all. So you're allowing oxygen to mix with the gas here so that you get a nice blue flame. If this amount of oxygen is not correct, obviously the combustion is not taking place and it will result in a soapy flame. Have you followed?
Flame is usually blue.
It is blue because we are adjusting this. Got it? Sometimes you will find that if your burners of the stove is also choked, then it can result in a yellow flame. So those burners have to be clean. That's why
Are
we
these
need-
sooty flames dangerous for us?
Yes. Sooty flame will basically not cause any danger for us because it's just a deposition of carbon which is taking place. But this is going to be dangerous, yes. Use of petroleum or use of coal is definitely more harmful as well using only hydrocarbons. Make a note of it, please. Okay. Clean flame. Come on. There are two things that I'm talking about. One is a sooty flame and clean flame. First point. Clean flame. What are the points you should remember? Is a clear blue flame. Okay, and it is given by a saturated hydrocarbon. Next point. Sooty flame,
Unsaturated.
hydrocarbon. Next one, sooty flame. Put a dash and write yellow flame with lots of black smoke. Usually given by unsaturated hydrocarbons. Okay. Another point to be remembered is fuels like coal and petroleum. Third point, fuels like coal and petroleum contain,
Continuation of soot flame.
no, point number 3.
Okay.
Point number 3, I said compounds like or fuels like coal and petroleum also have a small amount of what and what? Sulfur and nitrogen. Sulfur and nitrogen, which on combustion form on combustion. We are talking about combustion, not writing it down. Okay? On combustion form, oxides of, what is the first word you have written? Nitrogen or sulfur?
Nitrogen.
Depends on whatever you have written. If you have written nitrogen first, you write oxides of nitrogen, and then you will write oxides of sulfur. Whatever it is. Oxides of sulfur and nitrogen, which are major pollutants. That is something that you have to remember. Now we are talking such a lot about fuels. Why are fuels called as fossil fuels?
Because they take millions of years for formation.
Very true. You know how fossil fuels are formed?
Yes.
Then I decompose
Then
it of
decompose
trees
animals.
and lot of pressure.
Yes.
Form layers and layers.
Yes.
Layers and layers and after years.
And then due to
years,
high pressure, they form coal and
Yes,
other
true.
fossil fuels.
So what are the 3 states of fossil fuels?
It's
States.
it's a natural
Solid,
gas,
liquid.
solid liquid gas.
So basically it is solid. You may have a liquid fossil fuel, you may have a
Gas.
gaseous, okay, natural fuel, fossil fuel. Solid fossil fuel is nothing but coal, correct? So here we have got coal, here we have got petroleum,
Natural.
and here you have got the natural gas,
Oh.
okay? So here you can actually see, formation of fossil fuels. This part of it is, of course, most of you know. Let us say this is a huge forest. Okay. Now, gradually, because of certain climatic conditions, whatever, this gets submerged, let us say, by water. And then you have got deposits of sand, soil taking place, causes excessive amount of pressure and under high temperature conditions. Now, this part of it is getting converted into fossil fuel. Did you understand? We are talking about plant and vegetable matter, which contains carbon, hydrogen, and oxygen. Try to understand this. Okay. Under tremendous pressure, what is happening? This part of it is released as water. So what is left behind is nothing but concentrated carbon. Okay, under very high pressure. So that's when we are talking about fossil fuels. You have to dig deep inside in order to retrieve the carbon. Okay. Which one? Diamond is also, that is under special conditions of temperature and pressure. So in all places where you can get coal, definitely you will not be getting diamonds. Okay, it has to be formed and it is formed only under certain special conditions. Got it? Is that okay? Right. And here again, coal is of different types. Do you know? Anthracite. Do you know? Anthracite, heat, lignite. Bauxite is not. This depends upon the percentage of carbon which is present. So the best type of coal is anthracite, which contains almost about 90% of carbon. Is that okay? Do you understand? Look at the small paragraph which is given here, formation of coal and petroleum. The second paragraph.
Yes. Coal and petroleum have been formed from biomass which has been subjected to various biological and geological processes. Coal is the remains of trees, ferns, and other plants that lived millions of years ago. These were crushed into the earth, perhaps by earthquakes or volcanic eruptions. They were passed down by layers of earth and rock. They slowly decayed into coal. Oil and gas are the remains of millions of tiny plants and animals that lived in the sea. When they died, their bodies sank into the seabed and were covered by silt. Bacteria attacked the dead remains, turning them into oil and gas under the high pressures. They were being subjected to. Meanwhile, the silt was slowly compressed into rock. The oil and gas seeped into the porous parts of the rock and got trapped like water in a sponge. Can you guess why coal and petroleum are called fossil?
So basically we are talking about onshore, offshore drilling. You must have seen offshore drilling, where people have to go deep into the sea to drill for oil. Okay, because you are finding deposits in the seabed. Okay, so that's some kind of an example where they have given you to recognize the different type of fossil fuels. Now the next thing that we'll be talking about, do you want to continue in the class or outside the class? I can open the door, both of you can go and continue with your conversation outside. Choice is yours. Next we'll be talking about oxidation. Look at the next one. We have already completed with, what is the first one that we have spoken about? Combustion. Do you realize combustion is a type of oxidation? Yes, it's a simple thing. When you are having carbon combining with oxygen, forms carbon dioxide. Addition of oxygen is nothing but oxidation. But now why are we talking about oxidation once again? Because there are certain other things. It's not burning, but by certain chemical processes where oxygen is getting added on. Have you followed? Once again, sorry. Functional group. What is this functional group? Yes.
Only spheric or
Anybody?
alcohol?
Very good. Which group is this?
Aldehyde.
Very good. What is this group?
Carboxylic acid.
Do you realize that this is oxidation?
Yes. Hydrogen secondary.
So your aldehyde can be converted into a carboxylic acid by the process of oxidation. I've already told you that this oxygen and this oxygen is not the same. How will you write it?
Yeah.
This is the way it has to be written. Okay, so that is the reason why we don't write it as CO2H. No, because we need to also specify what type of oxygens these are. One of the oxygen has got a double bond, the other one is having a hydrogen, and the other one is to a carbon. Okay,
Why does it have a double?
why does it have a double bond? In order to satisfy its valency, that we have already done. Both of them oxygens have to be happy.
So now that has a single bond because it has to combine in the hydrogen.
Obviously. Is that okay here? Okay. Oxidation. Look at oxidation. Will you read?
You have learned about oxidation reaction in the first chapter. Carbon compound can be easily oxidized on
You have switched it off.
in addition to adding on the
And that
That's all. Can we switch on one?
And this
one-
fan.
Yeah, that's enough. One little bit of circulation is happening. Enough, one is enough. Good.
addition to this complete oxidation, we have reaction in which alcohol are converted to carboxylic acids.
Carboxylic acid. Okay.
And we call CH3 minus CH2.
minus होगा CH3 CH2 OH. What is that line show?
Single one.
Single bond. Okay. Fine. What compound are we started with?
Ethanol.
CH3 CH2 OH. What compound is this?
Ethanol.
Ethanol or ethanol. Okay. Next. Read.
We see that some substances are capable
What are we doing? We are converting into what?
alkaline KMNO4
In the presence of. That is in the presence of.
plus heat upon acidified
Or it is acidified
potassium
K2Cr2O7. What is that? Potassium dichromate. Okay, potassium dichromate. I'll put it up. Finally, what is the compound that you are getting?
CH3COOH.
Okay, now let's listen. Look at the board, everyone. Here we have got carbon 1 and this is carbon 2. We are talking about a process of oxidation. Okay, this I've already said. OH is getting converted into OOH. That means you're adding one oxygen. The number of carbons are going to be the same. So there's one carbon, there's a second carbon. But to the second carbon, we are adding an OOH. You see that? So instead of an OH, now it has become an OOH. So this is a process of oxidation. What compound is this? Ethanol. Which functional group is this?
Carboxylic acid.
So how, what will you say? Ethanoic acid. Oic acid. Okay? Or it is also known as acetic acid. You recognize this? CH3COH. Okay, CH3COH is your acetic acid. Now what are the what conditions is this conversion brought about? There are two reagents. One reagent is your alkaline KMNO4. You recognize KMNO4? Potassium permanganate.
Permanganate oxide.
Okay, this potassium permanganate. Or you can also be talking about acidic K2Cr2 potassium. Yes, dichromate. It is a dichromate. I'll give you, come on, take it up. Come on, quickly take it up. Okay. Oxidation of second point.
KMNO4 and K2CR7 are all they are catalysts.
They are oxidizing agents.
They are catalysts.
Which is the type of catalyst? Okay. Write down the first write down the reaction. This is what? It is ethanol. Ethanol. Because your functional group is an alcohol. That is getting converted into ethanoic acid. Ethanoic acid. Because your functional group has now become OOH. So there is an addition of an oxygen. Yes.
Ethanol and ethanol is the same thing.
No. Yes.
how is the catalyst? How is it?
Because
Speed of the reaction.
with not speed, it is supplying. Okay, it is supplying oxygen. It is an oxidizing agent. Okay. Because this KMNO4 undergoes some, it's not exactly a catalyst, it is an oxidizing agent. It is sometimes. Take it down. Okay. In words, I'm giving you now. First point. Ethanol or ethyl alcohol gets converted to ethanoic acid. What is the other name for ethanoic acid?
Acetic
Acetic acid. Yes. Acetic acid. Okay. It is getting converted to ethanoic acid or acetic acid. Okay. Next point. Alkaline KMNO4. Alkaline KMNO4. And in bracket write down what is KMNO4. Potassium
manganate.
permanganate. Or acidic K2Cr2O7. Look at the board if you are getting copy down the correct. K2. This is not. Or acidic potassium dichromate. Potassium dichromate. Are oxidizing agents. Okay, so these two are oxidizing agents. What are they doing? They are oxidizing the alcohol to an carboxylic acid. Next one, pick up. These oxidizing agents are adding oxygen to the starting material. What is your starting material? It is your alcohol. Yeah, where do you use it?
Or acidic, right? Potassium permanganate.
Or acidic potassium dichromate. You all get it? Yeah. 2 minutes can be reached.
2 मिनट में actually खत्म हो जाएगा.
Got it? अभी से कर चुका. Okay. Some work for you. Quickly. I'll be right now. I want you to all write down. Ready? Okay. Quick 5 questions. First one. I'll be giving you either a name or a formula. If I give you a formula, you write in the structures. Okay? Come on. No discussion. No discussion.
क्या करना है?
Structure. No discussion. If you want, you can take the help of your textbook quickly. But individually. Quick. How many carbons?
4.
Three.
CBSE.
Group. So what is it? 1, 2, 3. Put a double bond. And how many hydrogens? 6. 1, 2, 3, 4, 5, 6. What will be the formula?
C3H6.
And 6. What is the general formula?
General formula C2H2 plus 2 CN.
Cn CnH2n. General formula. CnH2n. Is it correct?
Yes, ma'am.
Cn. N is 3, 2n is 6. Yeah, can
Ma'am, have a formula written as CH2, CH3. Because
Next one.
Then on. Then on.
Mute is what?
5, 4, 3, 3.
All. Got it? Very good. What is it? 1, 2, 3, 4,
and 9.
and put an ON somewhere. Okay, you can put an ON here. So you have got 1, 2, 3, 4, 5,
C4H9 OH. C4H9 OH.
C4H9OH. Okay.
I made the diagram, but then I was the emergency I just
नहीं करोगे
I know I just converted the units and I got
Thank you, ma'am.
5 by 25 but
Thank you.
50 points. अरे मेरा बॉटल
Not comfortable.
पकड़ लिया लास्ट टाइम पॉकेट में
जाने की जरूरत है क्या
ये मुझे बुलाने का है।
दिल्ली बैग में मेरे को वॉशरूम आ रहा है
अबे नहीं मैं वॉशरूम लेके जा। कुछ भी बोलता है रे। ए रुकना अभी रुकना।
लाइट चालू है।